All right, so derivatives of trig functions, but before we do derivatives, we got to make sure we know the unit circle. So pause the video and attempt these unit circle problems. And if you don't know them, you've got to learn them. Like, this is going to be all year where we'll occasionally throw these in there. And so if you don't know them, you're going to be stuck. So learn them. I don't know what else to say. You're supposed to know them already. And maybe you don't have memorized super fast, but know it well enough so that you can draw little pictures and come up with the answers quickly.
Know how to get from A to B?
All right, so there's the answers. Check those. See what you think. Press pause if you need to on the video and see if you got them. All right, exploratory calculator activity. This takes too long if you do the exploring. So I'm going to do the exploring, and you're going to just kind of watch along with me. So mode, I want to be in function and radians, which is what it defaults to. So we're good there. I already have the window set. I've got y equals sine x in there. And just to remind you, there's what the graph of y equals sine of x looks like. Right? That's familiar.
Mm-hmm.
Yes? Starts at 0 and goes up. Period of 2 pi, which makes sense because we graphed it from negative 2 pi to 2 pi. So that, I hope, looks familiar. Remember last year we shifted it up and down and stretched it and all the different things to it. All right, what we're going to put in next is, this is kind of crazy, you can get your calculator to graph a derivative. So this just says take the derivative of y, of y1, when x is x. So this is going to take a little bit longer to graph because it has to go through each point and calculate the derivative.
How do you get those
symbols? Yeah, we'll worry about those later. I'm also going to make that one darker so that we can tell which one's which. Okay, so here comes the darker one. That's the derivative of sine.
Isn't that just cosine?
And that is cosine. So the discovery that we just made is that, wait a minute, the derivative of sine, just looking at the graph, is cosine. It says test your equation by entering it into y3. Yeah, we got it right. We're good. Repeat the process for cosine. So cosine of x. So let's remind ourselves what cosine looks like. Although that doesn't need a reminder. That's what we just saw. So there's function. I let y1 be cosine of x. And next I'll turn on the second graph. Take the derivative of y1 and graph it. This time don't call it out loud. Look at it. Think about it before saying out loud what you think that looks like. Again, don't say it out loud, but look at that and see if you can sort of in your brain think what function that is. All right, go ahead. What do you think it is? Negative sine. That's negative sine. So this is going to mess people up all year long because I guess because they're so similar and yet the sign is different, so that's the tricky part. They go together. Derivative sine is cosine, derivative cosine is negative sine. So that negative that's going to get people all year long because it's easy to remember they kind of go together. Make sure you put the negative on the right one. All right, next page, instead of working through all of those, we'll just tell you what the rest of them are. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent, you could do the same graph trick with tangent, like graph the tangent and then graph its derivative, but I'd be super impressed if somebody recognized the graph of secant squared That'd be pretty impressive. Really impressive. Derivative of tangent is secant squared. Derivative of cotangent, by the way, it's no accident the way we have these arranged. So we have sine, tangent, secant, and then cosine, cotangent, cosecant. Anybody want to guess if derivative of sine is cosine? Derivative of cosine is sine with a negative. Derivative of tangent secant squared. Derivative of cotangent is negative cosecant squared. So there's a little bit of symmetry or pattern going on here. Derivative of secant is secant x tangent x. And again, why that is, we can explain it, but it's better to just know it. And you could probably guess this last derivative.
Cosecant plus cotangent?
So negative cosecant x cotangent x. So I say memorize those four, have those down absolutely stone cold. The other two, I don't know. I usually have to kind of think about if I hit one. But if I know the pattern, if I know this table, I can figure out the other two. But I would have these four memorized because those are the ones we use the most. And if you know those four, you can figure out the last two. All right, some example problems. If y equals sine 2x, then dy dx equals, well, the 2 is still there. And derivative of sine is cosine, 2 cosine x. It's like pretty easy today. If g of x equals 17 tangent of x, find g prime. I'm going to write this one a little bit differently to show you some notation. Remember, d dx means take the derivative of. And just like you can add 5 to both sides or square both sides or divide both sides by 3, you can always take the derivative of both sides. So the derivative of g is g prime. And the derivative of tangent is secant squared. Number 3, some of you get flustered when there's like a fraction like that. But before we even take a derivative, what would be a easier, different way to write that? With that 6. Put negative 1/6 out front. That way it's a coefficient, you're not really worried about it. I want to take the derivative of, so the negative 1/6 is just along for the ride. The derivative of cosine is negative sine, and you could leave that as an answer, the 2 negatives in there, but I would clean that up. 1/6 sine of x. Number 4, find dy dx. This is just shoving 3 problems into one. Why don't you try number 4? So just handle the 3 pieces separately. All right, so you just take the derivative of the pieces. Secant becomes secant tangent, cosecant becomes negative cosecant cotangent, and then derivative of cotangent is negative cosecant squared. And I don't know if there's some way to combine those. I don't know, maybe, all those pre-cal rules, but we're not concerned with that. This is an okay answer. Number 5, what is the instantaneous rate of change? Ooh, fancy words. So what's it asking for when it says instantaneous rate of change? That's another word for what? Derivative. So just using different verbiage here. Of f of x equals cosine minus tangent when x equals pi over 3. So derivative of cosine is negative sine. Derivative of tangent is secant squared. And so now we get to test our unit circle knowledge here. Let's see, sine of pi over 3 is root 3 over 2. Secant of pi over 3. Secant goes with cosine. Cosine is, let's see, cosine's 1/2. So secant is 2. And actually that's a safe stop right there. I mean, the next step isn't hard, but that's a safe stop. Alright, 6 is basically the same thing, so is 7 and 8 somehow got reversed. Just to try one more, you try number 7 in that order. Try the bottom right problem.